தெரியாததெல்லாம் சொல்லி தொலைகிறது. ஸ்டாண்ட் வாங்கினா 20 வேலையே வாங்குது.
பாட்டில போட்டுக்கணும். அவனுக்கு வெயில் போனல அவனுக்கு
சொன்னாரு முடிஞ்சிருச்சு. இங்க எந்த பில் எங்க?
Hello, am I audible and is my screen visible? Okay, thank you. Hello everyone, welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Ayan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is the live session for week 8. So I will discuss some practice questions on week 8 topics, and I will also answer your questions or queries regarding week 8 topics. So in week 8, mainly knife-based Bayesian networks. These topics and some part of ensemble algorithms were also covered. So we will solve some practice problems on these topics. And if you have any questions or queries, you can ask me during this session. So we will start solving some practice problems first, and after that, if you have any other doubts, you can ask me. This is the first question. A man is known to speak the truth 2 out of 3 times. He throws a die and reports that the number obtained is 4. Find the probability that the number obtained is actually 4. There are 4 options. So this is on Bayes' theorem.
Sir, how many times he throws a die, sir? I didn't get, sir.
Yeah,
How many
only
times?
once. The die is thrown only once,
Oh.
and now he reports that the number obtained is 4. But the man doesn't speak truth all the time, so that's why it
So
might be
it's
4,
2
it
by
might
3,
not
2
be
by
4.
3 into 1 by 6, sir. It should be 2 by 3 into 1 by 6, right? Abdi Verma, I didn't get.
2 by 3 into 1 by 6, no, I don't think that is correct.
So it should be 2 by 3 only, sir. A only, sir. I believe so.
So 2 by 3 is just the probability of speaking the truth, but one information is given. So this is not just speaking the truth. The information given is that the he reports the number is 4. So what is the probability of actually getting 4? So some statement is given, based on that the probability of obtaining 4 actually 4. So that's why you have to apply Bayes' theorem. Yeah, I will discuss this question after all of you try it out. Okay, so for this question, first we need to consider 2 statements, and based on those 2 statements, we have to construct uh, what probability is actually asked here. So 2 statements are, first we consider this statement that A, that the man reports that 4 is obtained, and statement B is that number 4 is obtained. So if we consider these 2 statements, now what this question asks is that based on this data that the man reports that the number obtained is 4. So probability of uh, 4 obtaining 4 given that the man reports that 4 is obtained. So these two statements we need to consider first. And if we consider these two statements, this is the probability that we have to calculate, that probability of actually obtaining 4, given that the man reports that the number obtained is 4. So probability of B given A. So if we apply Bayes theorem in this, it would give us probability of A given B into probability of B divided by probability of A given B into probability of B plus probability of A given B complement probability of B complement. So now we have to compute values for these things: probability of A given B, probability of B, probability of A given B complement, probability of B complement. So first component is probability of A given B. So probability of A given B basically means that given that number 4 is obtained, what is the probability that the man reports that 4 is obtained? So that basically means is that he speaks the truth. So this is just the probability of speaking the truth, that given that 4 is obtained, what is the probability that the man will report 4? So this is simply the probability of speaking the truth, 2 by 3. And probability of B is obtaining the number 4 on the die, so it is simply 1 by 6. So these two are already obtained in the numerator. Now in the denominator, this probability of A given B complement. So probability of A given B complement basically means that number 4, given number 4 is not obtained, what is the probability that the man will report 4 is obtained? So that means he is telling a lie. So probability of telling a lie is 1 by 3, which is just the complement of this thing. So this is 2 by 3 probability of telling the truth. So probability of lying is 1 by 3. And probability of A given B complement basically means the probability of lying. And then this probability of B complement, uh, B is uh, B is the event of obtaining 4. So probability of B complement basically means probability of not obtaining 4, so which is 1 minus 1 by 6, which is 5 by 6. So now if we put these values into this expression, we will get 2 by 6. Is there any doubt in this question? So once you consider these two statements, it becomes easy to express the probability that is asked in the question. And after that you have to apply Bayes theorem and find out individual probability values in this expression. And those are mainly the probability of telling the truth or probability of lying and probability of getting 4 on the die. Now question 2.
Hello.
Yes.
Please explain the denominator part again.
So the numerator you have understood.
Yes.
So and here the first part of the denominator is simply the numerator.
Yes.
And in the second part, so probability of A given B complement into probability of B complement, these two things you have to compute. Probability of B complement means given that 4 is not obtained, what is the probability that the man reports 4 is obtained? So basically he is lying. So what is the probability of lying? If the probability of telling the truth is 2 by 3, probability of lying would be 1 by 3, isn't it?
Sir, but Bayes theorem is usually probability of B given A is probability of A given B, probability of B with probability of A only, no, sir. That's the Bayes theorem, right?
Probability of
B given A is equal to probability of A given B into probability of B by probability of A, where probability of A is evidence. And we tell
Yeah, probability of B can be expressed. This whole thing is simply probability of B, the denominator.
probability of A, that's the probability of A, you say. That's the probability of A, you say, right?
Yeah, it should be the denominator. Yeah, denominator should be probability of A. Yeah, it is simply probability of A. The denominator is simply probability of A can be split into two parts like this.
Right. Thank you, sir.
Now, question 2. Consider the following graphical model. So this is a Bayes network or Bayesian network. Mark which of the following pair of random variables are independent given no evidence. So each of these nodes are basically random variables. Now we have to find out which pair of random variables are independent given no evidence. So option A is A and B, option B is C and D, option A is E and D, option D is C and E.
So it should be A and B, sir.
Okay. Yes, Savanand Rajan says AB, Arundhati Das says AB. Anyone else? The correct answer is option A and B. So this is A, this is B. And if no evidence is given or no other random variable is given, A and B are independent of each other. As we can see, there is no serial path from A to B. And also this C is not given. If C or E was given, in that case, these two would not have been independent of each other. If C was given, that would be a path from A to B, and in that case A and B would have been dependent on each other. But C or E, no other variables are given. So if no variable is given, in that case A and B would be independent of each other. And in all other cases like EDC, we can find out paths which are not blocked from one variable to the other. For example, C and D. So if we consider the option B, C and D, in that case there is a path from C to D, and the node B does not block this path. So there is an uninterrupted path from C to D. If there is a path, there is at least one path from C to D, then C and D are not independent of each other. So to become independent of each other, there should be no path between the two nodes. But here we have one path from C to D. Similarly, for E and D, C and D, we can find out at least one path that exists between those two nodes. But for A and B, there exists no path.
Sir, does the direction of arrows is considered over here?
Yes, these are directed Bayesian networks. So we need to know these directions. Yeah. Otherwise,
So in that case, from
hmm?
C to D, how will traverse from C to D because the arrows are not
No,
in the
those
both.
arrows are different from finding out the independence. So
Okay.
uh, yeah, in the next question, in this question, it is much easier to understand because A and B, A and B don't have any other incoming edges, so they don't depend on any other nodes basically. So that way you can also find out. But there are three deseparation rules. I think that has been taught in the class. Three deseparation rules. Based on that, you can find out whether there is a path from some node to some other node. That I will discuss in the next question. For this question, it is much easier. Yeah, but for this question, we need to know the deseparation rules. While discussing this question, I will discuss those three deseparation rules. First, let us solve this question, then we will discuss this. So question 3 says, consider the following graphical model. Which of the following are true about the model? So multiple options may be correct. Option A says A is independent of B when C is known. Option B says D is independent of A when C is known. Option C says D is not independent of A when B is known. And option D says D is not independent of A when C is known. So basically you have to check each of these options one by one whether the statements hold or not. Multiple options may be correct. So for this question you need to understand the d-separation rules, 3 d-separation rules, and you have to apply those rules to find out the independence between variables given some other random variable. Sarvana Natarajan says AC. Arundhati Das says B and C. Okay. Sarvana Natarajan says A and D. Okay. Anyone else? Arundhati Das says B, D.
Sir, I'm sure that A is correct. The A is independent of B when C is known. And my answer was B is not independent of A when C is known. A and D is.
Okay. Okay, so for this question first, those of you who have studied the d-separation rules, they would be able to solve, but those who haven't, so there are 3 d-separation rules. So the first rule is consider this nodes x, y, z, and there is a directed edge from x to y, and there is another directed edge from y to z. Now we want to find out whether x and z are independent of each other given y. So if y is given in such configuration, X and J are independent. Independent if Y is given Y. So if Y is given, Y basically blocks this path. So this path x to j, Y blocks this path if Y is given. So if the path is blocked, X and J are independent in that case. If there is at least one path from X to J, then X and J would become dependent. So this is the first rule. Now the second rule is, so now Y, if there are two edges, one from Y to X, another from Y to Z. So you have to be careful about the direction of the edges. So both the edges are outgoing edges from Y. One is from Y to X, another is from Y to Z. In this case, same thing happens. If this Y is given, then X and Z are independent. So given Y, if Y is given, Y again blocks this path from X to J. Now the third rule. So third rule is a bit difficult, slightly more difficult than the first two rules. That
Please repeat second rule.
second is, there is an edge from Y to X and there is another edge from Y to Z. So this is the configuration. This is how the path would look like. Y to X, Y to Z, two edges are there. Now if Y is given, Y blocks this path from X to Z. In each of these cases, we want to find out whether X and Z are independent of each other, given Y. So in this case, Y blocks the path from X to Z. Also in the first case that happened, that Y is blocking the path from X to Z if Y is given. If Y is not given, that path is not blocked.
Okay.
So if all the paths from X to Z are blocked by some random variables, so X and Z becomes independent of each other. But if we can find out at least one path exists without any block from X to Z, then X and Z becomes dependent. In the third rule, so both the edges are incoming edges to Y now. So X to Y, this is one edge and another edge is from Z to Y. Both the edges are incoming to Y. Now in this case, it is exactly the opposite, that X and Z would be dependent or basically not independent given Y. So in this case, if Y is given, it does not block this path. It does not block this path from X to Z. In the first two cases, if Y was given, it was blocking the path. In this case, if Y is given, it does not block the path. And if it is not given, then blocks the path. So the third case is exactly the opposite of the first two cases. If Y is given, it does not block the path. So given Y, these two are dependent or not independent. So are these rules clear?
So actually, for in first two rules, if Y is given, then X and Y are independent, and in third
Yes.
rule, if Y is given, then they are dependent, right?
Yes.
Okay. Yes.
So
Hello.
now, yes.
Can you give some real life example of this dependency?
No, I mean real life example basically means this, on this graph I will show how these rules are applied.
Okay.
So first statement says, first option is that A is independent of B when C is known. So here is A and here is B. So we have to find out the dependency between A and B given C. So if C is known, so this path A to C, sorry, A to C and B to C. So this looks like this third example, isn't it? C has incoming edges from both A and B. So this configuration is basically the third option, third rule. So in the third rule, if the middle element is given, then there is a path from A to B, they becomes dependent. So here C is known or C is given. So A and there exists a path from A to B. So they are not independent, they are dependent on each other. So this is not correct. So in this case, basically in every case you have to find out all the paths. This was one path, A to C to B. There are other paths as well from A to B, like this is one path, this is another path. Among all those paths, you have to find out at least one path that is not blocked from A to B. And the very first path that we considered, this path, A to C to B, this was not blocked by C because of this third rule. So we have find out at least one path from A to B which is not blocked by any other node. So if there is just one path, at least one path, they are dependent on each other. So option A is not correct. A and B are not independent of each other if C is known. Now option option B says D is independent of A when C is known. So now D and A when C is known. So we have to find out the relation between D and A when C is known. So there are many paths from A to D. So this is one path. This is another path. This is another path. There are three paths, you can see. So we have to consider each of these paths one by one, and we have to check whether there is a path from A to D which is not blocked. So the first path is this, the shortest one, A to C to D. We can see that there is an edge from A to C, there is an edge from C to D which matches the rule 1, X to Y, Y to Z. So basically series connection paths. So if such a path,
Here, I have a doubt in first two rules, sir.
yes,
Why, given why they are blocking it? Because I didn't get that. X to Y, Y to Z is
no,
possible.
this is simply these are conventions that we use, those words that it is
I'm
blocking the
not
path.
talking about conventions. I'm talking about the path itself. Sir. X to Y, Y to Z. Y is given. Then X to Z, there should be transitivity, right?
No, no.
There should be relation, right? X to Y, Y
So
to Z.
these all
X to
these things can be worked out by mathematically, that probability of x and z given y, whether these x and z are, these rule basically means this, that x and z are independent given y, basically means probability of x z will be split into probability of x given y into probability of z given y, isn't it? This basically means x and z are independent given y. This can be worked out mathematically, but when you are given a Bayesian network, these rules are useful to apply. If you work out mathematically that if y is given, you will find out that this rule, this holds, that you can split probability of x given y and probability of z given y. So basically means x and z are independent when you know y. So these rules make those calculations much easier. You don't have to work out those probabilities, Bayesian theorem. You don't have to apply Bayesian theorems. By just analyzing the paths from one node to another, you can find out whether the nodes are dependent or independent. So these are the just literals that are used, like blocking the path, not blocking the path. These are used to make those calculations much more simplified. All these things can be easily done using the probability theorem and Bayesian theorems. Not easily, but it can be done, but the calculations will become much more difficult and much more rigorous. But using these rules, you can easily find out. For example, so this was I'm doing so. A to C to D, this is the path. So this is one edge and this is another edge. So this configuration matches the first rule. So if C is known, C would block the path from A to D. So if C blocks the path from A to D, A and D becomes, so this is one path that we have found out that this path is blocked. But there are other paths from A to D. This is one path. Now we have to analyze whether this path is also blocked or not. All the paths have to be blocked in order to become independent of each other. First path, the ACD path was blocked. Second path, ACBD, this path, whether this path is blocked or not.
Sir,
So
excuse me, sir.
yes,
Sir, how to reach from C to B, sir?
no, these you are considering these edges. You don't have to, for analyzing the independence of variables, you don't need to follow these paths. You have to follow these paths to apply these rules, but you just have to find out any path regardless of the direction. You consider simply this
Okay,
path.
sir.
You consider this path without considering the directions. Now analyze this path based on these rules. For applying these three rules, you have to now know these directions of edges. But to find out the paths, you don't have to analyze the you don't have to consider the edges. So this was the path ACBD. So there are two components of this path. First is ACB, then this CBD. So this ACB path, if C is known, ACB path matches this third rule, that the middle element has edges from both the sides, incoming edges from both the sides. So this ACB matches this third rule, and if C is known, it does not block this path. So this path is not blocked. Now the second part of this path, which is CBD, this path. CBD matches this second rule. So in the second rule, if the middle element is given, then they are independent. The path is blocked. The middle element here is B. So B is not given in this question. C was given in this question. C was given only. So B is not given. So B does not block this path from C to D. So this path exists. So this path also exists. So basically means this whole path from ACBD is not blocked anywhere. So if we can find out one path that is not blocked from A to D, A and D are dependent on each other. So we have found out this path which is not blocked. A, C, B, D, this path is not blocked by any of the nodes. So A and D are not independent of each other. So this option B is also not correct. Now option C says D is independent of A and A when B is known. So again D and A, and when B is known. In the previous option it was C, C was known. Now it is B which is known. If B is known, so we can easily see that this path exists. A, C, D. This is one path from A to D. And this path is not blocked by C. If C was given, C would have blocked this path. But if in this case C is not given, only B is given here in this option. So C is not given, C cannot block this path from A to D. So there exists a path from A to D. So they are dependent on each other. If the path was blocked, then it would have been those D and A would have been independent of each other. So there exists a path from A to D, which is ACD, uh, which is not blocked. So D is not independent of A is correct. And option D,
Excuse me, sir. Sir,
yes,
excuse me, sir. Yes, here we are saying ACD uh, is not blocked, but C
yes.
is there in the partner.
See if in the first rule, if the middle element is given, because this
Then,
here you have to apply the first rule, A to C,
yes,
C to D edges
yes,
are.
sir.
So first rule is applied. In the first rule, if the middle element is given, then they are independent.
Independent.
Here middle element C is not given, only B is given.
Okay.
Yeah, middle element C is not given, C cannot block this path. If C was given, it would have blocked this path. So this path is not blocked, A, C, D. So
You have to see the diagram and the statement and relate it.
which diagram?
We have to see the given model and then according to the options we have to connect it.
Yeah, you have to find out each path from, for example,
Oh,
for
yeah.
the option C, each path from A to D and analyze whether that path is blocked or not. If all the paths from A to D are blocked, then they are independent. And if you
Hmm.
can find out at least one path which is not blocked, in this case, this ACD path is not blocked, so they cannot be independent of each other.
As C is not given there in the option.
No, in the option C, B was given, but in option B, C was given.
Hmm.
In that case, C would have blocked that path. Then we have to find out other paths and whether the other paths are also blocked or not.
It's quite difficult to.
Yeah, this is slightly difficult. You also have a question in the assignment also. There's a big
Yes,
diagram
yes,
given. You have to find out the independence and dependence. So basically, uh, you have to first understand these three rules, and then you have to apply those rules on small networks and try to understand what is actually happening.
Hmm.
And also there are some videos in YouTube. You can see, you can just search desuppression rules and their examples. There are
Okay,
some videos available from where you
okay,
can understand. If
okay,
if you're not able to understand from this tutorial, then you can
okay.
look it up.
Okay. Yes.
And the fourth option, now third option is correct. Fourth option says D is not independent of A when C is known. So this is simply the exact opposite of option B. That option B was D is independent of A when C is known. Option D says D is not independent of A when C is known. So we have already found out that B is not correct. So certainly it is the exactly opposite. So D has to be correct. And it can also be shown using these three rules, but it is not really required. We have already worked out option B, which was wrong. So option D has to be correct.
Hello.
Yes.
Sir, regarding the option B and D,
Hmm.
suppose in B, D is independent of A when C is known. So
Yes.
here, if C is not known, then D is definitely dependent on A.
Yes.
It seems like that. And the moment we have information about C, I whatever I need in D, I can get everything from C,
From
right? So
C,
in
yes.
that
So
case,
that's why
asking,
you don't have to know what was the value in A. So that's why A and D becomes independent. If C is known, C cuts that path. You don't need to. The D is no
yes.
more related to A.
So in that case, B should be correct, right, sir? You have
D,
marked it as wrong.
D is no. You have to find out for every path. This was one path which was blocked. Obviously, because of C, this path was blocked. But I analyzed the other path. This one. This is another path. If you can find out at least one path that is not blocked, then they cannot be independent.
But in option B, they are not talking about the part considering the B node. It is only
No,
the considering the
it
C
is
node.
going. No, C is known. Here C is known, but
Hmm.
you have all the other paths. This is one path, this is another path. C is only known. It is not saying that you have to only consider paths along C. And also these each of these paths are going through C, isn't it? All these paths are going through C. But it's not about whether all the paths are going through C or not. You can have other paths which are not going through C. Still, you have to analyze those paths. You could have had a direct edge from A to D. In that case, it is not going through C, but a direct edge from A to D basically means A and D are directly related. They are certainly dependent on each other. So you have to
Yes.
analyze all the paths, not just those paths which go through C. So in the second path, this path was not blocked. For this, the we broke this down into two parts: ACB and then CBD. So this ACB was not blocked, but this CBD was blocked by B. Here, B was blocking this. Oh, sorry, B was not blocking this path. So this whole path was not blocked. So that's why this whole path was not blocked. So we have found out one path from A to D which is not blocked by any other nodes. So these questions are slightly difficult. You have to first uh, understand the rules properly, and then you have to apply those rules on those Bayesian networks. You have to find out all the paths from the two nodes for which you want to find out independence, and for all the paths you have to apply these three rules and find out whether the paths are blocked or not. If you can find out at least one path which is not blocked, they cannot be independent. And if you have found out that all the paths are blocked, then they have to be independent of each other. So correct options are C and D. Now question 4. Two cards are drawn at random from a deck of 52 cards without replacement. What is the probability of drawing a 2 and an ace in that order? So in this order, first a 2 is drawn and then an ace is drawn without replacement. What is the probability of that? Devashish Paramanic says option D. Saurabh Sahgal says option B. Okay. So what is the probability of drawing drawing a 2 and an ace in that order? So what is the probability of drawing a 2 from 52 cards? So there are 4 2s. So 4 divided by 52 is the probability of drawing a 2. And without replacement, now you have to draw an ace. So again, there are 4 aces, but one card is already drawn. So the probability of A should be 54 divided by 51 when one card is already drawn. So the total probability would be, the probability of drawing a 2 and an S in this order would be 4 divided by 52 into 4 divided by 51, and it would be 4 divided by 663, I think, option D. So first the probability of drawing a 2. Now in the second event you are drawing an S, but now there are only 51 cards because we are drawing without replacement. One card has already been drawn, so that's why the probability of drawing an ace would become 4 divided by 51. Out of 51 cards, you have 4 aces, so probability of drawing an ace in the second draw would become 4 divided by 51, and then you have to multiply the two probabilities. Question 5. A drug test denoted by random variable t has 1% false positives, that is 1% of those not taking drugs show positive in the test, and 5% false negatives, that means 5% of those taking drugs test negative. Suppose that 2% of those tested are taking drugs. Determine the probability that somebody who is tested positive is actually taking drugs. So two random variables are already denoted. First one is the random variable t, which denotes the uh, outcome of the test. T means tested positive, and negation of T means tested negative. And random variable D is the event of taking the drug. So you have to find out the probability that somebody who is tested positive is actually taking drugs. So this question would take some times because there are many terms like false positive, false negatives, and given, and there are random variables associated. So I will show you the steps here. So the first probability given is 1% false positives. So here false positive means that 1% of those not taking drugs show positive in the test. So this probability is basically um, they are not taking the drugs. So given that they are not taking the drugs and given negation of D or complement of D, the probability of testing positive, that is this 1%, that is false positives. They are not taking the drugs, yet the test is showing positive. So this is probability of T given D complement. T is the output of the test, and D is whether whether certain person is taking drugs or not. And now the second probability is this false negatives. So 5% false negatives means 5% of those taking drugs test negative. So they are taking drugs, but they are showing negative in the test. Given that they are not taking the drug, uh, given that they are taking the drug, the test shows negative. So probability of complement of T given D, that is false negatives, and it is given as 5%, 5 divided by 100. And the third probability is 2% of those tested are positive, are taking drugs. So basically this shows percentage of people taking the drug. So probability of D. So that is 2%. And the probability that is asked in the question is probability that somebody who tests positive is actually taking drugs. So somebody who tests positive is actually taking drugs. So given that somebody is tested positive, what is the probability that he or she is taking drugs? So probability of D given T, this is the probability that you have to compute. So now we will apply Bayes theorem on this. So first, this probability of T given D we have to compute. T complement given D is given here, 5 by 100. So that is simply 1 minus probability of T complement of given D. So it will become 1 minus 5 by 100, which is 95 by 100. PD is given here 2%. Now this one, probability of T given D complement, that is already given here as false positives. Probability of T given D complement, so that is 1 by 100. And probability of D complement is 1 minus probability of D, which is 98 by 100. Probability of D is here 2 by 100, so complement of that would be 98 by 100. Now we have computed or found out all the different components of this Bayes theorem. Now we can put these values into this equation and find out the required probability, which is probability of D given T. And if we compute it, the answer is 0.66, option A. Is it understandable?
Sir, you are not taking into account true negatives, right? False positives, false negatives you are taking.
Yes.
Uh, but what about true negatives? True positives you have taken, right?
No, you
True
don't have
positive
to
are not taken.
compute the all the values in the confusion matrix. These false positive, false negatives are given so that you can find out these probability values which are required in your required probability of D given T.
How can you say drug test as 1% false positives
Yes,
and 5% false negatives?
yes.
So it should be the rest of it should be 0.94, right? 0.94. That's not the that should be the any point. So that should be rest of the things
Yeah, that
0.94.
should be the, I mean, yes, that is the true positives and true negatives. But that is not what is asked in the question, isn't it? That what were the values of true negatives and true
But
positives?
we are getting we need only true positives, right?
Yeah, that is what we are computing here, probability of D given T, that we can find out using the Bayes theorem.
So problem this is a problem of t. What you have computed in the denominator is problem of t actually.
Yes, probability of T can be split into two components, otherwise you cannot find out probability of T.
T given D
The
को निकालना
expanded base theorem is always given like this. The denominator is expanded. The shorter form of base theorem is just the P of T, but you need to expand, otherwise all these components you have to use, otherwise you cannot find out probability of T directly. You have to use all the other probability values.
Thank
Okay, move on to the next question. A patient goes to a doctor with symptoms S1, S2, S3. The doctor suspects disease D1 and D2 and constructs a Bayesian network for the relation among the disease and symptoms as the following. So this is the Bayes theorem that is constructed, and the ages are also directed like this. So age directions need to be considered here. What is the joint probability distribution in terms of conditional probability? So joint probability distribution basically means probability of S1, S2, S3, D1, D2. So basically probability of joint distribution of all the variables. So what is this probability in terms of the individual random variable probabilities and the conditional probabilities? Saravanan Natarajan says option D. Okay. So to find out these joint probability distributions, first you need to segregate the variables which do not have any incoming edges. So this D1 and D2 don't have any incoming edges, so they are independent. Individually they are independent of all the other nodes. So in the conditional probability you can simply separate these variables out: probability of D, probability of D1, probability of D2, because they are not dependent on any other variables. Now for the other variables, first we take S1. S1 is dependent on D1, so we have to write probability of S1 given D1 based on the direction of the age. The age direction is from D1 to S1, so it would be probability of S1 given D. Now
I think
for
answer B. B. B for Bombay.
answer would be D. And then for the second for the node S2, now S2 has two incoming edges, one from D1, another from D2. So we have to write
Yes.
probability of S2 given D1, D1 comma D2, and finally the last variable S3 has one incoming edge from D2, so we have to write probability of S3 given D2. So this matches option C. Yes. Sorry, option D.
D for Delhi.
Yes. So first you have to individually write down the probability of those random variables which are not dependent on any other variables. They don't have any incoming edges D1 and D2. So you can simply write those variables like this: probability of D1, probability of D2. Now for the other variables, you have to uh, consider the variables which it is dependent on. S1 is dependent on D1 only, so probability of S1 given D1. S2 is dependent on two variables d1 and d2, so probability of S2 given d1 and d2. And finally S3 is dependent on d2, so probability of S3 given d2. Now question 7. In a Bayesian network, a node with only outgoing edges represent a variable conditionally independent of the other variables, a variable dependent on its siblings, a variable whose dependency is uncertain, none of the above. Saravanan Natarajan is option A, Arundhati Das is option A. The correct answer is option A. If that node has only outgoing edges and it does not have any incoming edge, then it is not conditionally dependent on the other variables. Now question 8. Which among gradient boosting and ADA boost is less susceptible to outliers
So in
considering
the
their
previous
respective
question,
loss
can
function?
you
Yes.
demonstrate some example?
Which one?
The previous question.
So
Yes.
for example, you can consider this previous this one, this in this diagram, this D1 node don't have any incoming edges, so D1 is not conditionally dependent on any other node. That's why we can simply, in the joint distribution, we can simply write probability of D1 because it is not dependent on any other nodes. It doesn't have any incoming edges, it only has outgoing edges. But the S1, S2, S3, each of these uh, have some incoming edges. That's why we have this probability of S1 given D, probability of S2 given D1 and D2, and so on. So question 8. Which among gradient boosting and ADA boost is less susceptible to outliers considering their respective loss functions? ADA boost, gradient boost, on average both are equally susceptible.
Sir, I want to know what we mean by outliers means something which is present as a false, it's a missing data or something as it is, or something missing data in this one. Outliers.
Outlier.
Outliers means something like a which is
Now
present in.
outlier means those are noise points which should not be given much importance in the data. For example, these are all positive points, these are all negative points, but suddenly you have one negative point among which is very close to the positive point. So this negative point might be some outlier or noise point, because of noise of your sensors or other things. This point has occurred, but it should not be given much importance. The model should be uh, less susceptible to those outliers and noise points. Devasis Paramanix is option B. Okay. Arundhati Das is option B. The correct answer is option B, gradient boost. So gradient boost uses squared error. So it uses squared error, but ADA boost uses exponential error. In the ADA boost expression, you can find out that this dt plus 1 is proportional to dt into e to the power minus yi alpha I ht xi. So this e to the power, this expression Because of this expression, the loss function becomes exponential, and if the loss function is exponential, for the outlier points or noise points, this error value becomes very high because of the exponential function. But in the squared error, those outlier points are not given that much importance, because the squared error of those for those noise points are much lesser than the exponential error of those nodes, and we want these
Doubt is you're getting a loss function. You're telling a loss function. That's a error, right? Entropy or a loss function, something loss function. If it is
yes.
exponential means then how it is less susceptible, sir? It will
So this is
encode.
what I'm explaining. Let me explain first. So the exponential error for the noise points, the exponential error becomes very high because the noise points are very far away from the actual points. These are the negative points, but the noise negative point is situated here. So for this straight line, if this is your straight line, this error value is much higher. So in case of exponential error, the error value for the noise points becomes very high. But in case of squared error, the error for the noise points are not as high as exponential error, because exponential function value is much higher than the squared function value, and we want the error value for the noise points to be very minimal, or even if we can, we should ignore those points, find out which points are noise points and ignore those points, but but which is very difficult to do. uh, but we should give much lesser importance or much lesser error value for the noise point, so that it does not hamper the actual decision boundary.
So I didn't get, sir. Again, I didn't get, because you are saying you should minimize the loss function. You're
Yes.
less susceptible outliers in a sense. You should minimize the loss function, right?
Yeah,
In that
minimize
case,
loss function. So, but for the outlier points or noise points, we should not give them much importance. Error for those noise points should not be very high that it hampers the overall error function, because they are very far away from the actual decision boundary and their actual position where they should be. The negative point should be somewhere here, but it is situated here. So the error value for this negative point should be very high, isn't it? It is completely in the opposite side of the decision boundary.
so error point is higher means then what do you say? It is when error point is higher. You want to say when error point is higher, uh,
Error value for the noise points are very high,
very high, right?
and in case of
So it's
exponential loss functions, that would become even higher, isn't it? We're taking exponent of the actual error, but in case
loss
of
function is
squared error,
higher.
that is much lesser. In squared error value is certainly much lesser than the exponential error
This
value.
is oh, right, I got it, right. Thank you.
So the gradient boosting uses least square error loss function, while error boost uses exponential loss function. AdaBoost penalizes outliers to an exponential amount, whereas gradient boost penalizes them to a lesser extent, thus cares less about them. If the error value is very high for some point, that point would dictate the position of the decision boundary. But we don't want the noise points to dictate the position of the decision boundary, so their loss error value should be minimal for the noise points. Now question 9. How do you prevent overfitting in random forest models? Increasing tree depth, increasing the number of variables sampled at each split, increasing the number of trees, all of the above.
I think it's B. B for Bombay.
B, okay. Sarvana Natarajan says C, Devasis Paramanik says C. Okay.
C is the right answer.
Okay. C.
No, C cannot be the answer, because when you increase the number of trees, overfitting happens?
Now the correct answer is actually C. If you increase the number of trees, basically in case of any ensemble algorithm, if you increase the number of classifiers, it reduces the variance, and by reducing the variance we can prevent overfitting. The characteristics of overfitting is that variance would be high, bias would be low. But in case of ensemble algorithms, we've already studied that variance is much lower than the individual classifiers. And if we reduce the variance, overfitting can be avoided. Option C is the correct answer. Now question 10. Ensembling in random forest classifier helps in achieving, this I have already discussed, that variance becomes lower. So this question is not really needed to be discussed. I already explained that in case of ensemble algorithms, uh, the variance of the resulting ensemble classifier is lower than the variance of the individual classifiers, and that's why you can prevent overfitting. And decision trees can overfit very easily, and if we create random forest models, then the overfitting issue can be prevented by adding more and more decision tree classifiers in the random forest. Yeah, the correct answer here is reducing the reduction of variance error. So these were the questions that I wanted to discuss in this live session. Now, if you have any other questions or doubts, you can ask me.
Sir, will these questions will be shared to us?
Yeah, these video lecture links and these slide links would all be uploaded in uh, the links would be uploaded in the problem solving sessions tab.
Sir, actually, I don't know about others, but I'm very difficult in following sir's lectures.
Okay. Yeah,
And
but if you,
it's complete mathematics. So
yeah, it is. Machine
my
learning is
question would
about
be,
mathematics, so you have to go through all those
yeah, I
things.
agree, but it's completely mathematics and nothing else. So my question would be like this. So what is that extra efforts we have to make to follow him nicely?
Mm, so if you want to understand everything about the mathematics part of it, uh, in the week 0, I think some linear algebra and some other topics are covered, which are just introductory things that are required in machine learning. So if you have not gone through those things, you can go through those to understand the mathematical part which are needed for the machine learning algorithms. And otherwise, if you don't understand a specific algorithm that is taught, specific part of it, then you can simply look it up in the YouTube and in other lecture videos. There are many lecture videos available in other online course platforms, and also in YouTube. Free lectures are already available there on all the topics of machine learning. And
Excuse me, sir. I've not attended most of the classes. I was busy with some other work with my academics. So I was not able to attend all the videos. I was not able to go through all the videos. Will there be any lectures like I'm attending another session on cryptography. They are giving lecture materials as a PDF materials, PPT PDFs, or else written handwritten notes or something as such. Will
yeah.
that be available for the year or anything like that? Whatever he is writing on the board can be taken into handwritten materials.
I don't think those are available. And also, we don't manage these live session TAs, we don't manage those things. So, if you want specific material, you have to ask the instructor or the regular NPTEL TAs that are there for this course in this semester. So, you have to ask in the discussion forum, but I don't think any written materials apart from those that are already there in the portal you can find out. I don't think
Those are
there are.
videos are lengthy. Videos are lengthy. So if we have got a material, we can slightly go through those material. So that would be
No,
probably
I
I
don't
thought.
think any other material is available. But you can ask in the discussion forum. The regular TAs would be able to answer because we don't have anything. We don't manage all those things. So
And
we
moreover,
can.
I want to know about the backpropagation algorithm and so the neural networks part of it. I haven't touched it at all. Others are something okay, but on neural networks, I haven't touched it at all. So there would be the backpropagation algorithm, feed forward, feedback, some algorithms is there. What's it? ABN, and I forgot Adeline and Madeline networks or something. I forgot. So I need to go through those. But the videos are lengthy, so I thought of getting some handwritten notes. But if it's possible, please pick it up. Thank you, sir.
Hmm.
Thank you for it. Right.
Yeah, the videos are slightly lengthy, but if you want to pass this course, you have to go through the video lectures. I don't think other materials are available, but you can ask in the discussion forum. The regular TAs would be able to help if they have the, any other notes for this course. We don't have
Excuse
any
excuse me, sir. When is the exam? NPTEL exam?
exam. Exam still. This is only week 8 happening, so it's still I think at least
April
1 month.
April 26th, madam.
26th April
April
Okay,
26.
okay, okay, okay.
Sir,
And one
can
more
you
thing.
please explain
One more
concept
thing.
of random forest?
Yes.
Can you please explain the concept and working of random forest?
Random forest is basically you are using many decision trees, nothing else. You create multiple decision from the actual data. You randomly sample sub data from that sub data sets basically, and for each sub data set you train a different decision tree, and then finally aggregate the output of all the decision trees. It is a simple ensemble algorithm. You create multiple decision trees and you combine the output of all the decision trees finally to get the final output.
Combining means will you take the average?
Yeah, in case of regression you will take the average, but in case of classification you will take the majority vote generally.
Okay, 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 okay. A majority vote is KNN, right?
No, KNN is simply K nearest neighbor. So
Uh,
you
there
find
also we
out
take the
the
majority vote.
here. You have three decision bound decision trees. In case of classified, you have two classes 0 and 1. If out of three decision trees, two are saying class 1, one is saying class 0. So obviously class 1 wins. So that's how
Mhm.
you find out the final
Okay.
class in classification. But in regression, it is generally simply the average.
So whatever K means clustering, sir, you take into account some Gaussian K
Sir, I
means
have one doubt, sir.
Yes,
So normally we talk about logistic regression, right?
yes.
But actually it is classifying, right?
Yeah, it is actually a classification algorithm, but the naming has been given such a way from long time
From the
ago, so it has
beginning, I
not
have a
been
doubt
changed
about it.
since then.
It's only classification, right?
Yeah,
If
it is
there's a
it is
threshold,
simply
above the
classification.
threshold,
Yeah,
it is 1. Below the
yeah,
threshold, it is 0.
yeah. The name might be confusing initially because it is saying regression, but it is not actually regression. But the
Okay.
name is like that for a long time now, so it is given as shown. So it is logistic regression, but it is a classification algorithm, obviously.
Hello.
Yes.
Hello, hello.
Yeah, yeah.
Please explain the first question in details. I means how to derive those deseparations rules and
No,
in this
derivation of
case.
deseparation rules are not given in the lectures, I think. Is it there? I
Means
don't think it is.
logically, how we infer those things logically. Means,
Yeah, it would become very lengthy. I have also not worked out all the rules there, but you can try it out yourself because simply you have to know only one formula, which is the Bayes theorem. And independence basically means so if we want to find out the independence of x, z given y, so if we can prove that this, sorry, this that x and z can be separated given y, then x and z are independent. So you can if you can prove this based on the uh, decision based on the Bayesian network that we have, then we can say that x and z are independent, but the derivations are not given in the video lectures also, I think, because it would become very lengthy and there are too many steps involved in it. That's why it's easier to
Means I want to ask means how to remember those things or logically to connect those things.
no, the three rules you can easily remember, isn't it? This is one configuration. Sorry, this is one configuration. This is another configuration, and this is another configuration. Sorry. Yeah, three. For the first two cases, they are independent. For the third case, it is dependent. That's it. And in all the cases, the based on the knowledge of the middle element, whether if we know the middle element, then what is the relation between the first and the third element. This is a simple three rules you have to remember, and also you have to remember it in case of the final exam. You don't have all the lecture notes available with you to work out there, so you have to remember these three rules, and three rules are really small. These rules are really easy to remember.
Sir, I have a doubt, sir. These rules will
Hmm.
be represented as a mathematical equations, right?
Yeah, this is
Can
what
be
I
represented.
told. This if you can
This
prove
rule,
that
what you say, problem x comma z given y.
yes.
That's which rule, sir? This one. This one which comes out of which this one?
No, so
Which
this
graph?
depends on the Bayesian tree that you would have. Some Bayesian tree you would have, and
Oh,
there would be some x, y, z nodes, and
right, sir. So what is it? So what rule it applies there? We say P of probably of x comma z given y.
so these
So
are these are relations. So the total, the joint distribution you have to write out separately, separate probability distributions. From there, you will get the conditional probabilities, and those conditional probabilities have to be applied to prove this that x and z can be separated given y. But that proof is not also given in the lecture videos, and also not really required for this course. You have to simply remember the three rules to do that.
these
Hallelujah.
these values, these graphs don't represent
No,
a.
no.
Alright.
Graphs?
Here, Hallelujah.
Yeah, I couldn't hear you properly.
Okay, sir, thank you, sir. But just I want to know whether these graphs you have drawn three graphs, no, sir. They are usually a mathematical model, right? Mathematical
Yes.
equations.
Yeah,
Thank you,
so
sir.
this Bayesian network can be written by this joint distributions. From the joint distribution, you get the individual conditional probabilities. So the Bayesian network is simply a mathematical model, obviously. And these edges represent relations that y is dependent on x or x is dependent on y based on the direction of the edge.
So while considering the paths, should we consider the directions or only the connections?
Your voice is breaking a lot. I couldn't hear you.
Hello?
Hello.
So while considering the paths, so should we
Hmm.
consider the directions or
No.
without directions?
First for taking the paths, you don't have to consider the directions, but to apply these rules, you have to take the edge directions into consideration.
Okay.
So,
So if
for
there are
so in this
multiple
example, this is one path which is irrespective of the direction of the edges. This is one path. You don't consider the
okay.
direction of the edges while taking the path. Now, when you try to apply the separation rules, you have to consider these edge directions.
So can we answer this question with the help of finding that conditional probability for each case?
Consider the following
That would
graphical
become
model.
that would become very lengthy. That's why you have the
Lengthy,
separation
okay.
rules. That's why you have
Yeah,
the
but
separation rules. You don't work out the
right, but
math completely. These rules simplify the mathematical part of it. You don't have
yeah,
to
that is.
separately write down the joint distribution and the conditional probability distribution separately. You can apply these three rules to find out.
But for taking the other paths, it is quite difficult. डायरेक्ट गिवन है पाथ तो इजी है वो अप्लाई करके 3 रूल से निकालना.
Hmm. But yeah, for
बट
so
फिर
something like
बाकी के
this
पाथ
path, you
के
have
लिए
to separate.
हाँ,
You have to separately consider this part of the
yes,
path and this part of the path.
yes, yes.
Sir, but in
So,
the exam, very difficult questions are asked.
Yeah, I mean, such a question is there in the assignment also. One network is given, and you have to find out the dependence and independence. In week 8 assignment, I have seen not this network, but on a different network that is given.
So, yeah, can we find
Sir,
some
please,
list for practicing?
actually, I option C here.
Option C.
I could not get that things how it is true. So can you
Okay,
please
I
explain this?
option C. Then I have to go through all this. It would be better if you. I will certainly upload this video lecture and I explained that why this is happening.
Okay.
Simply because this is easy, so I can really show. B is given, and we want to find out the dependence of A and D. So we have this path. This is one path out of three paths we have. This is one path. This is another path. So first we are taking the easiest path. This one, A C D. So this B is given, but C is not given. So C is certainly not blocking this path from A to D. We have found out one path that is not blocked. So the D and A cannot be independent of each other. So
Now
that's why option
suppose
C is better.
C is given, then
Then that question is covered here. Option B. Option B says that C is known. Then you have to apply C. For applying for that, you have to consider other paths as well. You have to find out one path that is not blocked. That is the main thing.
okay.
Yeah, you can watch this video once again in YouTube if you don't understand it right now. I've already explained it multiple times. So if you don't still understand, you can look it up in the YouTube anytime you want.
What
A
is the
link
topic
should
we have
So
to see?
at a time we have to consider three nodes only.
yeah, for every path
Means
you consider three nodes. First three nodes,
hmm,
then second three nodes, that way.
So, this topic is graphs, right?
okay.
It is Bayesian networks.
Okay.
Okay.
Yeah.
So thank you
I
everyone
think
for joining. Hmm?
Hello.
is it
Yes.
covered in the Bishop book?
thank you, sir.
Yeah, it is. It should be covered in the Bishop book. It is there, I think. Most of the topics are present in that book. Oh no, there are two books referenced in this course. I don't know if it is present in the Bishop book, but the other book, which is called Elements of Statistical Learning or something, that name. In that book, it is, I think, there. There are two books referred. You can download both the books and check in which book it is present.
Okay, okay.
Hello.
Okay, sir, got it.
Okay. Thank you everyone for joining.
Hello. Hello, sir.
Yes.
Sir, I wanted to ask like all the binary classifier
Mm.
using one versus all or one versus one, we can
Mm.
extend it for multi-class classification, right?
Yes.
For all binary classifier.
Yes.
Perceptron, suppose perceptron algorithm is there. It is
Mm.
again basically a binary classifier only.
Yeah.
Using one versus all, we can still extend it for multi-class classification.
Yes. Yes. Yeah. You can
And what
extend it.
about uh, MP neuron? It is also inherently a binary classifier. Can we extend it for multi-class?
Which
MP
classifier?
neuron. MP neuron.
MP
Maculopit
neuron.
neuron.
Is it there in the course?
Uh, yes, I think so. It's a part of neural network, right?
MP neuron. I don't. MP neuron.
MP neuron, like maculopit neuron.
Oh, Maculopits neuron.
Yes.
No, those neural networks are very basic actually. They only
Those are
consider
very
binary variables, isn't
Sorry.
it? Those neural networks, those are earlier versions of neural networks. They only consider binary inputs, I think.
Yes, it,
Maculopits
it
in
considers only binary
binary.
inputs.
They cannot be. I have never seen applications of those in uh, multi-class classification, probably because they are not used anymore these days. But I don't know. It can be extended, whether it can be extended or not. I don't remember the exact structure of it, but those work only on binary inputs, so they are not really realistic nowadays.
Yes. In case of perceptron, which can take real input, it can be extended for multi-class classification,
Yes, yes,
correct?
yeah. Perceptron can be extended.
Mm. Okay. Thank you, sir.
Thank you. If there are no other doubts, we can end this live session now. Thank you everyone for joining. We will meet again next week.
Thank you,
Okay,
sir.
thank you, sir.
Okay, sir. Bye bye. Thank you very much.
Thank you.